So, hello everyone. So now let's proceed to the chapter 2.5, the properties of Euclidean group. But before anything else, I would like to introduce myself. I am Mary Jean Hermin, your instructor for this day.
So now, let's proceed to chapter 2.5, the properties of the Euclidean group. In this section, additional properties of motions are considered. Theorem 2.4. The four basic Euclidean motions of the plane constitute a group of formation. As you can see in the image moving, the first one is the reflection and the second one is translation. Theorem 2.5. Every plane motion is the product of three or fewer reflections, and conversely. A. Every translation and rotation is the product of two reflections, and conversely. Note that the two cases depend on whether the two lines intersect or are parallel. So these are the intersect example. To get the intersect of Euclidean motion, the theta will be moved to in this position, and the L sub 1 will be moved in this position. So as well as the L sub 2 will be moved in this position. So these are image of product that L sub 1 and L sub 2 move. The reflection of O and 2 theta is equals to reflection L sub 1 and reflection L sub 2. So next is the parallel. R and PQ and P prime and Q prime is equals to RPQ and RP prime and Q prime. Remember, a TP is equals to R L sub 1 and R L sub 2. So B. Every reflection or glide reflection is the product of three or fewer reflections. As you can see in the image, the mirror is reflect and translated. So these are the image moving. The first one is translation, and the second one is reflection of glide reflection. So let's proceed to types of motion. As you can see in the table 2.2, the product of two reflection is in A, if the two lines of reflection are parallel, then the motion is a translation. And letter B, if the two lines of reflection are non-parallel, then the motion is a rotation. While in product of three reflections, A, if two of the lines of reflection coincide, then the motion is a reflection. And B, if the three lines of reflection are parallel, then the motion is a reflection. And C, if two lines of reflection intersect at a point on the third, then the motion is a reflection also. And lastly, the D, if two lines of reflection intersect at a point not on the third, then the motion is a glide reflection. So the products of types of motion. So as you can see in the table, if rotation and rotation, the product is rotation or translation. And if the rotation and translation, the product is rotation or translation. If reflection and rotation, the product is glide reflection or reflection. And if glide reflection and rotation, the product is glide reflection or reflection. As well as in the translation and reflection and glide reflection, it's just the same. Para makuha ninyo ang product, ang translation ag rotation, these are the result of their product. So mao na siya ang paagi sa pagkuha sa product. So next definition, a plane motion is a direct motion. If it is the product of an even number of reflection, it is an opposite motion if it is the product of an odd number of reflections. In image 1 or moving image, it shows the translation of direct motion, while in B, it is the reflection of opposite motion. So these are the direct or opposite motion. So we can see, as we can see in figure 2.26, the image 1 is a direct motion, while the image 2 and 3 is a opposite motion. In table 2.3, direct and direct, their product is direct, and if direct and opposite, their product is opposite, and opposite and direct, their product is opposite, and if opposite and opposite, their product will be direct. So motions invariant points. In table 2.5, the motion are translation, rotation, reflection, and guide reflection. So the possibilities of invariant points: in translation, it is none. In rotation, the possibilities for invariant points is 1 point. In reflection, the possibilities for invariant points is 1 line. While in glide reflection, the possibilities for invariant points are none. Theorem 2.6. A unique motion of the plane is completely determined by an isometry of one triangle onto a second. So as you can see in the image, the first triangle will be constant, but it will change their position and their variable, like a prime. From A, it will be A prime, and B, it will be B prime, and C, as well as C, it will be C prime. So isometry. These are the example of isometry. The figure 2.27, the first image of 2.227 and the image of 2.2 image of 2 will be the same, but their position will be changed as their variables. It will be changed into A, from A to A prime, and B to B prime, and C into C prime, as well as a P into P prime. In figure 2.28 also, the image 1 to the image 2 will be changed position because of this P1 and P2, and it will change into P prime 1 and P prime 2. So these are the example also. Prove that a segment and its image are parallel under translation. In figure 2.29, triangle A prime, B prime, congruent triangle B prime, B A. So these are the triangle of A and A prime, B prime, congruent triangle B prime and B A. Thus, angle of A prime is congruent to B prime AB, and their line segment AB parallel to line segment A prime and B prime. So same lang sila. So the image are parallel. So that's all for 2.5 about the properties of Euclidean group. Now let's proceed to chapter 2.6, motions of 3 space. There are 6 motions of 3 space, which is translation, rotation, reflection, rotary reflection, screw displacement, and glide reflection. Definition: The transformation T sub A such that T sub A of x is equals to x plus a is a translation of the space in direction OA. So the following equations for three space transformations are analogous to transformation of a plane. So x prime is equals to x plus a, y prime is equals to y plus b, while in z prime, x is equals to z plus c. So these are the image shown, the motion of x prime. So mo balhin rin na siya diri, pwede na siya maglihok-lihok. So example, in figure 2.30, the x has 1, 2, 3, and a has 2, 4, and 8. Remember that t sub a of x is equals to x plus a. Then, to have the answer, we will only add the x plus a, so that we can have the result of 3, 6, 11. So the 1 add 2, so the result will be 3, 6, 11. So that is the answer for the t sub a of x is equals to 3, 6, 11. So definition: the rotation r L alpha in 3 space through an angle alpha about a fixed line is a rotation in a plane perpendicular to L. So in figure 2.31, this is the rotation in a 3 space through an angle alpha. For a rotation in space, if the fixed line is z-axis and the plane is xy plane, then the image of a point can be found using the previous rotation equations. For a point in a plane parallel to a xy plane, the z coordinate will remain constant. Example, if x is rotate, x will be rotate, it will be constant, while the z and y will change. As well as in y, if it's rotate, the z and x will be changed. As well as the z, if rotates, the x and y will be changed. So x prime is equals to x cos alpha minus y sin alpha, and y prime is equals to x sin alpha plus y cos alpha. Definition: a reflection r sub phi in 3 space is a reflection about a plane such that for P and its image P prime, phi is the perpendicular bisector of segment P prime. So as you can see in the figure 2.32, this 2.32 and the other image is a reflection in 3 space of for reflection about the xy plane, the image of ABC is AB negative C, hence x prime is equals to x, y prime is equals to y, and z prime is equals to negative c. The corresponding sets of equation can be written for reflections about the xz and yz plane. If x and z, the result will be negative y, and if y and z, the result will be negative x. Okay.
So that could be all. Thank you for your time and effort for listening my reporting. I hope you learned something and have a great day. God bless everyone.